Good afternoon,
Yeah.
Hey.
ladies and gentlemen of Precalculus. We're working on more exponential functions today.
Can I do something for Hannah? No.
What do you need to do for Hannah today?
Good morning, Mr. G.
Good morning.
You're welcome.
Very good. So I don't know if it's going to be this one here or fifth period.
Well, it better be this one now.
Yeah, we'll see. Probably, yeah. Unless too much other things get into it to foul the transmission. Anyway, we're good so far. So anyway, look at number 21, and I want to see what you think about this to get observations. Fifth period had some good observations about this. How to
It
create.
exists.
It looks hard.
It exists. It exists.
It goes up a little more than double.
It's a positive.
It starts low, ends high.
What would you say?
It starts low, ends high.
Starts low, ends high,
It's bounded
It's
below.
odd.
bounded below,
Does it hit the
exponential. So that's
x-axis?
so starts low, ends high. That's an exponential what kind of function?
Increase.
Growth. Thank you.
God will get it right.
But that's increase too. Increase is a good word too. But growth is the one we talked about Friday, right? Growth and decay. Good job. Okay, what else can you know about this function? Let me just write down. We'll write down the standard version of a function here. So we're using a y. So I'll put y equals a times b to the power of x. So we're going to fill in and complete. Find out what a and b are. That's essentially what we want to do here. Any ideas?
A is 4.
So a equals 4. A equals 4. How does Kayla get a equals 4?
It's the intercept.
The y-intercept. Very good. So y is equal to 4. Okay, so now it's really just a matter of finding what our base is. Well, if we find that base, that'll be our answer. How do we find what our base is?
2.0125.
So base equals 2.0125.
Yep, that's under it.
Okay, well,
That's
that's a good, I think I know the intelligence, there's a lot of intelligence going there. How'd you get 2.0125?
8.05 divided by 4.
Okay, so 8.05 divided by 4, so is that gonna be a correct answer?
No.
Why not? How did you know it's not? Because you tested in your calculator, right?
No, because I'm stupid.
No, she's not stupid.
Oh, yes I am. I see what I've done.
Oh, no.
So have you fixed it? You know what?
Attempting to.
She's gonna fix it.
What is it?
I want
Is it 1.0125?
You have
No.
to subtract the 1.
no.
You have to add.
What is, there's a little complexity of analysis.
You
Now,
have to square and then multiply, then divide.
Kayla would be, this would be exactly right if this point, instead of 5, 8.05, was instead 1, comma 8.05. Then this would be it exactly
So
right.
does it have to be over 5?
Okay? I want to show you some logic for how to find that.
Please don't.
And what it is, if you have like x, y, and you have here 0, 4, and down here at 5, you have an output value 8.05. What happens is we have not only 0, but intervening, we have 1, 2, 3, 4, then 5. And so the base is going to be the number that you multiply by 4 to get this output, and then multiply again by the same number to get the output at 2, multiply again here to get this output here, multiply here,
By 5.
and then lastly, so how many B's do we have here?
5.
What?
5. So some number multiplied itself 5 times is going to equal
5.
what? So what happens is the base that Kayla calculated was not b, but it was rather b to the 5th power. Right? So what we have is b to the 5th power is going to be the quotient of 8.05 over 4. And so how can we solve for B?
Is it 1.1501?
Yes.
That's what I got.
So B is equal to the fifth root of 8.05 over 4. Which, Angel, you said was
1.150.
1.150, I
More.
think it's 013 or something like that, right?
Yeah.
Okay.
Yeah, well, what happens is the book actually just culls out and makes this 1.15, so I'll put the book's version in here. And then we can also test with the calculator to see how accurate it is. We should be a little bit short with it. So we have 4 times 1.15 to the power of x, and then we go to table view. We should see pretty, whoa, that's not what we want. Let me go to, I'm gonna go to table start of 0. There we go. Yeah, so almost 8.05 at 5, right? So that's going to be our answer. So this is going to be our answer to this question. Now what I want to do is I want to have you work out number 22, and I'll pick on somebody here in a couple minutes. Similar type of problem. Yeah, let's see, 6th, yeah. Turn out some paperage. You
I'll
guys
do this one.
want to do it? I'm gonna call somebody randomly. A lot of good trees are sacrificed to make your running better.
Well, maybe you should quit sacrificing so many trees.
Well,
Save the
the
trees
thing,
though.
yeah, that's right, saving trees is good, but you know something, I do a lot to help save trees otherwise, much more than I use the paper. You know what I do?
What do you do?
Use a baby plant.
No, I have electric solar panels on my house. And they tell me how many tons of tree mass I save every month with that electricity generation. Okay, I'll shoot somebody.
He's like you, dude. He's like you. Oh, I didn't get that.
Yes.
Kayla, you wanna pick up Jackson?
Yeah, 0.36.
Kayla, you wanna pick up Jackson for me?
Doesn't look familiar.
Do what?
Do you wanna pick up Jackson for me?
You gotta take, I think
I thought
it's
this
a
was
cube
is
root,
it drive?
I was gonna go get the kid and.
fourth root.
No.
No, what you gotta do.
I can't drive.
1.49, then divided by 3 has to go
Car
inside.
seats in my car, if you ever wanna walk them over.
Then you'll have it. Okay, good. Okay, Jana is just about there. I'm gonna choose somebody.
Kayla's just driving by in there.
Okay, here we go. I'm gonna shuffle this a couple times.
Oh, please don't take me.
It's gonna be
Please be me. I have the answer. Me. I'm gonna hop out the window. Please be me.
It's gonna be Adam. Adam chooses Adam a lot. Adam, you're just
I'm always first.
you're a magnet, Adam. Magnet. Number wheel magnet. What did you get, Adam?
Did you put my papers?
Y equals 3 times,
I bet you fix.
0.839.
so 0.839 to the power of x. I think that's the version the book has too. And how'd you do that? Did you get your base?
How'd you do it?
You should get base as the fourth root of
Yeah.
1.49 over 3. And then you're going to get that, okay?
Yep.
And then you can test in the calculator. And that's pretty simple, right?
Yep.
Right, thank you, Ed. Okay, we're going to go to the next problem here. Here, I'm going to save this gold one here for Kayla.
Yellow is sus.
I like yellow, it's my favorite color.
Oh, okay, maybe I won't save,
Why
maybe I'll
it's
save it
sus.
for later.
But I never get it.
Actually, most of these are red and yellow, turns out. Oh, well.
Because you said we're going golden.
Okay. All right, the next ones we're working with here are population growth problems. And,
Word problems, not.
yeah, word problems, sometimes they can cause trouble for people. Does that intimidate you?
Yes, they intimidate me very much, I hate words.
So what you want is you just want the naked numbers by themselves problems, yeah.
Naked, I like them.
Okay, well, Carmen, you don't need to tell us too much about yourself.
You have Carmen, don't tell us too much about yourself. It's a little awkward.
Okay, very good. So what would be your approach to this problem here?
I would underline everything I need.
Which would be,
I'm gonna know that.
All the numbers you don't need.
Not all of them, because some of them, okay, so you're
All
gonna
the
need that
numbers
one.
you don't need.
And you're gonna need
2,000?
that one. And you're gonna need the percent one. And then you'll have to do that one.
Oh yeah, so what's that? All
Excuse
the
me, yours are hot.
numbers?
Sometimes it's
Isn't that
not.
all the numbers?
Okay. Let me show you, I'll show you the general format of these equations. P of t is equal to our initial amount, P sub 0, times 1 plus r to the power of t. Okay, does that make sense? Yeah. So filling in, we want to find out at that rate 1 million per year, so 1 million
Hey, Angel, can you stop?
is equal to our initial amount, which is 736,000.
How many zeros is that? 6.
And then we have R is going to be equal to 1.49%, which equals, without a percentage, will be 0.0149.
And Mr. G, can you erase a 0, please? On the 1 million.
Because that's too many,
Oh, my eyes are
No,
playing tricks on
It's,
me.
it's a million.
Yeah,
1
it's-
million. See, you make the little, yeah, so that's right. So those are right, but that's actually good because you do that. And that's why they have little commas between the zeros to make sure your places are right, which could have been wrong, but in this case it's right. So we have 1 plus 0.0149, so this could be 1.0149 to the power of t. And so that's going to be what we can use. Now how can we solve the equation solve this equation? There are really multiple ways of doing it.
Subtract 736,000.
1 plus 1 equals 2.
No. We'd subtract if that was added. It's not being added, right? It's dividing. It's multiplying by. And I'm going to show that later, but what you can do is you can put this in the calculator, this right side, and see when your output value equals 1 million. Does that make sense? So we go to calculator, we put in 736,000
Yep.
times
Seven, yeah.
1.0149 to the power of x. And then we can check where. We can check our table, and what number are we looking for on the right?
1 million.
1 million. And so we see that We're getting close.
21.
Yeah, so by year 21, now, it doesn't with the rounding give us exactly there, but by 21, we'll say by t equals 21. And so what year is that going to be?
2021.
So 2000 plus 21 equals 2021. So by 2021. I want to show you a couple other ways to solve it, and for the purposes of accuracy, this is a very good, this is plenty accurate. But I want to show you something else you can do with this to get more precision. What you can do is graph a second function, which is 1 million, and then we have to get our window set up right. So I'm going to go, that's going to be enough time, 25 years. I'm going to go from zero, minimum will be fine, or yeah, this will be fine, right? 1.1 million. So we graph, and this is what we see here. Do we see an intersection point?
Yeah.
Yeah, how do we find the intersection point? Second trace 5, enter, enter, enter. And so what do we get here? 20.725, which is by year 21, right? So that's another way to do it. I'm going to show you yet a third way that kind of goes into where we're going next in our class, and it's this.
Caleb.
Adam's on his phone.
Well,
How are you?
he's using a calculator. All right. So I want to show you something here. I'm going to show you algebraically solving for t right here. And remember what Angel said? He said subtract 736,000. No, we're not going to subtract it. We're going to divide by it, right? When we divide by it, what happens on the right side? Cancel, right? So what we have is we have 1.0149 to the power of t equals 1,000 over 736. Any questions on that so far? You see how I got 1,000 over 736?
Yes.
I just canceled a bunch of zeros, right? I just canceled, 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 and this is what's left, okay? Next, how do we solve for t right here?
Use the root of t.
No, it's not, yeah, okay, that's an example. What happens is that this is 1.0149 to the power of t, which we don't know yet, equals 1,000 over 736. So what I'm going to do is introduce to you is something called a logarithm. Okay, a logarithm is what power do we raise this number to equal this. And to write this, we write it as log base. Now the base of the logarithm is the same as the base of an exponent, and we write it right down here. Log base 1.0149 of 1,000 over 736 is going to be equal to t. And we're going to be doing logarithms shortly. So it's like you move the t over here and make this the base of the logarithm, move the 1,000 over 736 over to the other side. And so now we can put this in a calculator, and I want to show you how to do that, is that we go here, and I think it's in math. I forget sometimes where it is. So it's math, and we go to base, there it is, A, and if you want to, you can just go to alpha A for that, You press this, so you go base 1.0149 of, we'll put, was it 1,000? Yes, 1,000 over 736. Do you get the same thing here?
Yeah.
Yeah. So that's one, I've introduced this now because that's one place that we're going to be going to shortly in a course, dealing with logarithms, which are like an inverse of exponential functions. So that's it. Now what I want to do is call on somebody to do problem 30. Are you working ahead on problem 30? It looks like people are. You've done problem 30? Okay, Kayla's done it. Let me give another minute or so. So Kayla, have you worked out the whole paper yet?
No, only to the front side.
See, only the front side. Sometimes, a lot of time, Kayla will just,
Come on, Phil, speed it up.
Angel?
Speed him up.
what I want you to do, if you see Emily, if you see Emma, if you see Emily, Emma,
Kinsey.
and Kinsey,
Anna?
and I tell, if you could mention to those three girls I just mentioned, that to go ahead and turn in their work. Emily and Hannah have been turned in their work. Okay, let me go ahead and choose somebody. And it won't be Adam this time. Here we go, let me shuffle once.
Who's the kid?
All right, here we go.
You got 2015.
So what is it?
It's gonna be Jana.
130?
Yeah. Did you done to it?
All right, Jana. What did you discover?
I got by the year 2013.
So Jana says by man, this, I got a pen just decided to go glitchy on me. By 2013? Okay, how did you work that out?
I did 1,000,000 equals 478,000. Times 1.0628 to the power of t.
It's a power of t. And did you get that using a table? So using the table, she scrolled down and found that. Does anybody need me to go through that right now? Anybody have questions about that? So you got by year 13, so 13 years. And I think when you worked it out, it's like 12 point something. So by 13 years later, so you got 2,000 plus 13 equals by 2013. Any other questions on that? Or any questions at all on that? Okay, pretty simple. Okay, next we get into the situation of Smallville. So just work on that for a couple of minutes and then we'll see.
Set these for yours.
Okay. Yeah, so I'll show you what you did. So you worked 31, 32 already? Okay, this one here. I don't know, do you want me to show you how to do this, or you want one of you to show me how to do this?
I've already done it.
You already done it? Okay, Kayla, you go ahead and take over. Tell me what you've done. Got here.
Okay, well, I got y equals 6.6 times 1/2 to the power of x divided by 14. It halves once every 14 days, so x divided by 14, that's what we did last time.
No, 31, not 32.
Oh, 31. I thought you said you were talking about half-life.
We're talking about.
Oh, well, okay. On that one, I have A is 12,314 to 24,264. And then B, I have around 1967.
Okay, by 1967. And what are the numbers you had up here for this one?
12,314 and 24,264.
264.
Mm-hmm.
Okay. And how come for this one here, how come you didn't round up to 12,315? Do you know why you didn't do that?
Because you can't round a person. If it's half a person, it's still not a person.
Yeah, she's right.
I put it in,
Yeah, but
I wanted to
I
graph.
put it in the graph, and I forgot.
I put it in the graph.
I got it.
If you
Half
have
a
0.1 of
person
a
doesn't
person, you should have the rest of the person.
If there's 0.1 of a person, there's nothing there to be a person.
It's
Okay,
the-
well,
It's the,
No,
it's the.
as a matter, you can make an argument for that, but as a matter of technicality, Kayla's actually right. So that's why I asked
It's
her
the
that.
1800s also, no, they're this.
Wow, Angel.
Anyway, but what it is, you have P of T is equal to 6250 times 1.0275 to the power of T. And then if you just plug in, and then Kayla, how did you do this? So that's how you would do this problem here.
Mhm.
How did you do part B?
I just figured out when it reached 50,000.
Did you use a table
Yes.
for that? No, so she used a table and then got to that and added, was it 77?
Oh, no, I just plugged in 77 to the actual problem. That's what it was. I just started plugging in years.
Oh, you started plugging in? Okay, well, very ambitious. But 6250, so 6250 times 1.0275 to the power of x. And then if I'm gonna go to table start here of 75, just because that's pretty close. Then we go here and we see that between year 76 and 77 that we went over 50,000, right? So by 77 years, and which is, so how do we get 77? 1890 plus 77 equals 1966, or 1967, excuse me. Okay, questions on that one? Good, I will give Kayla some credit for that. And then this one's the same thing, right? Let me spin a wheel for that one. We've got Kayla's already. Gonna be Angel, all right, Angel. Oh boy. All right.
I'm still doing it.
You're still doing it, okay. Just keep kind of working on it a little bit.
When you're like,
And what I want to do for this class today is I want to finish with 32. So we'll come back and Kayla and Will were already starting to talk about 33, which I'm glad you did, but I'm going to finish those tomorrow. And get I'll get these handed out as much as I can. We've got it for us?
Yeah.
Okay.
make it work.
What do we got here?
Down.
I have B, 1980, by 1982.
By
I got
1982.
1981. I think they're right.
We'll talk about that in a minute. Okay.
By 1930, it'll be 6,554.
6,554?
Yeah. Yeah.
Okay.
And then
And
9,150.
9,150?
Yeah.
Okay, by 1930. Okay, and then we have, is it 1.0225?
Yeah. From here, this is the logarithm thing.
Oh, you did?
Yeah.
Okay, so let me go to do it that way. So you did the logarithm, so you had 20,000
Yeah.
equals 4,200 times 1.0225 to the power of t. And so you divided, and you got 1.0225 to the power of t is equal to 20,000,
200 divided by 42.
oh, 200 divided by, right, you can abbreviate, right, yeah. 200 divided by 42, so you get, that's to the power of t, 1.0225 to the power of t. So t is going to be equal to the logarithm base 1.0225 of 200 over 42. Is that right?
Yeah.
Let's do that. I want to show you this in the calculator here. What you can do is you can go to math, and then you can go to alpha A. It takes you right to it. And 1.0225, and here you got, was it 200 over 42?
Yeah.
And here he gets 70, and 70 plus, well, it's supposed to be 70, right? You give me 82. So you get 1910 plus 70, so 1980.
Yeah.
So 1980, all right, but still that's some good work there, okay? So we'll just leave it right there, and then we'll go to our half-life problems that Kayla and Will were talking about tomorrow, okay?